Welcome to the Harvest 2020 Spot Farm Results Week. The live stream session will start shortly. Before we begin, we want to remind you of some housekeeping. You will stay muted throughout the live session, so we can't hear you. The session is scheduled to be either 1 or 1.5 hours long, including questions. To ask the speakers a question, use the stage chat found on the right-hand side of your screen. Please do not ask questions for the live session in the main events chat. This session will be recorded and will be available to watch again on the AHDB Potatoes YouTube channel and the AHDB website. At the end of the session, we will provide you with a unique basis and Naroso code, which you should keep note of for each session that you attend. Don't forget to apply for points using the basis and Naroso application forms, which can be found in the reception area. Join the conversation online by following AHDB Potatoes on Twitter and use the hashtag SpotFarmResults2020. Finally, if you have any issues with the conference platform, contact the team on events@ahdb.org.uk. We hope that you enjoy the Harvest 2020 Spot Farm Results Week. Your session will now start.
Hello and welcome to the AHDB Spot Results Week. This morning we will be talking about desiccation. Sorry, I might just repeat that because I'm not sure everybody got it. Welcome to the AHDB Spot Results Week. This morning we'll be talking about desiccation, and then what we're going to be looking at is the results from our spot farms and looking at alternatives to Diquat and how effective they were in 2020. And we're going to open the session by introducing Mark Stalham, who will go through the results from the field, and then we'll have discussion from the three host farmers. And please do ask questions as we go through, and we'll respond at the end. I'm hoping that we get plenty of time to speak to the farmers who actually we're going to look at what happened last year, but also how we can implement into planning stages for this year. So please do stick with us, ask questions, and we'll make sure we include you in this session. So thank you for being here. I will hand over to Mark Stalham, who will give us the results from 2020.
Good morning, everyone, and thank you, Claire, for that introduction. You can see there basically the title, and I will go through a couple of slides in a moment explaining where we used Diquat as a comparison in 2019, but most of you will realise that we weren't able to use it in 2020. But I really want to thank all of the people on the bottom there for 2020, but in particular who aren't listed there are the coordinators of the project, Anne Stone and James Martin, who commissioned the work back in May 2019 and continued. And so effectively, I'm presenting on behalf of all the consortium partners here. There's no attribution to me. I no longer work at NIAB CUF, but I'm an independent now, but I'm presenting the data on behalf of NIAB CUF. So if we sort of look through where we're actually at in terms of slides, we go through slight technical issue. I'm having a problem moving forward on slides. Okay. Just bear with me a second, technical issues, and I will be here with you. So can everybody see my slides? Claire, can you see this? Hello, Claire.
I can see it now if you move forward.
Okay.
The desiccation home screen at the moment, but it did move forward.
Okay, we're fine now. Okay, up and running. Can you see that, Claire? Can you see the next slide?
Yep, it's there.
Okay,
we're on to the things.
A bit of a late. Okay,
thanks, Mark.
So, okay, right, 2019, 2020, we had similar aims, which was to find the best alternative to Diquat. And in alliance with the work that we did in 2019, which you'll see a summary of in a moment, the N management, nitrogen management of the crop was particularly crucial, we felt, and that was introduced, as you'll see, in 2020. So as a summary, we've done this several times now. I'm going to present it in isolation in terms of 2019, then go on to 2020 in more detail. But the summary is there in terms of skin set, which is what we're really trying to achieve. In terms of canopy, death, stem desiccation, so on, they're routes to get to the skins actually setting and being able to harvest. So throughout this entire presentation, all of the final harvest skinning data will actually be assessed on a scale that if the number you can see in that second column is less than 15% of the surface area of the skin removed, it should be acceptable for harvesting over most commercial harvesters. So we're looking for numbers less than 15. So you can see there in 2019, a summary of 7 total trials. If we did nothing, clearly the figure in red, we've got a delayed skin set there, but it does actually get there eventually if you leave it long enough, but we can't wait that long. So if we use Reglone, on average, by 3 weeks after the initial application of a first chemical or mechanical treatment, none of those treatments on average across those 7 demonstrations or experiments had reached the critical level. So realistically, when you start looking at some of those differences of 2, 3, 4%, that's only materially about 1 to 2 days difference in skin set. Now, that's an average, and it hides what we've got here in this slide. So you can see the 7 trials there. Some of them are experiments where we've got more confidence than the trials data. But you can see there that basically 2 of the sites, the Spot North Ware and the Spot North Seed, actually were remarkably good in terms of skin set. The Elvedon, again, pretty close. But the one that stands out is the Spot Southwest Ware, which was setting skin very quickly after initial T1. But the Spot North Seed and the Spot Scotland, you can see in the first 2 columns, and the Spot West Ware with Royal did set skins much slower than the treatments on there. So that's the Reglone comparison. Realistically, as we say, most of those differences are only 1 or 2 days in terms of skin set once they've reached it. So practical recommendations are, you'll see this repeated in the next 3 or 4 minutes about foliage death and the link between skin set. So I won't repeat that, but there was a poor relationship there. On average, there's this 1 to 2 day delay for the PPO chemicals that we use, Spotlight and Gozai, compared to the traditional Reglone, which we've lost, mechanical, i.e. home pulling, or really the more commonly used flail, or the new chemical that we used in 2019, Soltex. And you've got to factor that in. If you're trying to get out of the field by a designated date, it's going to take you 2-3 days to achieve that skin set with the worst chemicals by comparison. Anything that showed signs of active senescence at the timing of T1 when we applied chemicals or flail was killed almost immediately, and skin set occurred very rapidly. So we'll return to that during 2020. So you can see in 2020, the sites were similar, though largely not in the same geographical location. So we had Scotland, the West, North and East, but the sites did vary as we gained different hosts throughout the program in 2020. So you've got the hosts in the audience. We'll be talking about that in this session afterwards. But what we've got there is basically a range of 3 ware crops, 1 seed crop, and particularly with the seed crop in Scotland, where we're growing a very short season crop, then maybe nitrogen management really comes into importance there about getting the optimal balance between partitioning between tubers and foliage to get the crop up to the level of yield required and size, and then out of the ground. So as I mentioned right at the beginning, one of the theories was to get a crop maybe just tipping over the point of natural senescence. If we reduce the nitrogen level by an amount, would that have an effect on the speed at which we got skin set, the rapidity of canopy growth decline, and also the rate of which stems began to harden or fall brittle? So you can see there we chose 15% less nitrogen as a management committee, and you can see the differences in rates that we've got there as a consequence, and those sort of rounded to the nearest number. So you can see here the treatments. I won't dwell on this in terms of the treatments because they will appear repeatedly in tables and figures. But very quickly, we've got 3 comparisons and a nested factorial design. And the nested factorial design involves nitrogen at standard RB209 rate and the reduced rate. And that appeared on the control, i.e. nothing done. The Saltex treatments you can see at the bottom, and the Spotlight Goes Eye Spotlight combination treatment that we use there. So we can factor in there the effect of nitrogen, and I'll come back to that almost right at the end. So we've got the timings there. Traditionally, we would do at 7-day intervals for timing T1, T2, and T3, and even T4 if we needed it, 4 weeks after the application of a T1. But because we did a flail treatment, a mechanical treatment, we were following, if you like, average practice, which would be to apply a PPO inhibitor effectively 3 days after that initial flail. Now, it can be done on the time of flail, it can be done up to 7 days later, but it was chosen to be 3 days later. So what we've got there are these T2A and T3A treatments, which are actually applied 3 and 10 days after T1, whereas all the other treatments were applied at 7-day intervals. And you can see the products we're using there. And the T4 application 21 days after T1, you can see if we needed it, was a Goes Eye application. These are recommended rates in combination that we're using there. And you will see on the bottom, the Saltex rate was basically half of what we used in 2019. So 562 litres used as a neat application, but all of the other chemical controls were diluted in a 400 litre per hectare volume. So just to make that clear, 400 litres, but the Saltex was higher. So very simply, every experiment followed this similar pattern. You've got a location diagram there and a plot plan layout. The green areas are areas where we basically had to adjust the nitrogen to a different level, so raise it up to the RB209, whereas the white plots were a base level, 15% lower. The randomization changed, but the blocking design and the layout of the experiment was identical at all 4 of the sites in 2020. And they are all experiments with 4 replicates. So we're going to go through, and what I'm going to do for brevity is to basically go through the Spot East and the Spot North wear trials as being combined because they showed very similar effects. Then what I will do is combine the Spot West and the Spot Scotland seed site to actually compare those where kill of the foliage and skin set was much more difficult. So you can see here, this is Mike Shapland's field. Mike called me basically up and said, I think the crop's going off earlier. We basically brought forward desiccation by about 12 days from our original program. And looking at this crop here, you can see it looks like it's beginning to go off. If we look at the control treatments here, looking down from above, you can see there's a little bit of soil beginning to appear, but the crop is definitely on its way down. And so bear that in mind when we start to compare the results of the chemical and the mechanical treatments. Spot North, very similar picture here. We've got Maris Piper. Looking more closely, you can see a bit yellower, but again, the canopy's opening up. And again, that site was brought forward in 2020 because we were getting the canopy beginning to tip over. That's close fail. That was typical of the Spot East and Spot North treatments. Slightly variable flail length, but trying to aim for that 15 to 20 centimetre target for the PPOs to hit 3 days after this timing was applied. So you're now going to see a series of ground cover curves, and very simply, I'm going to bracket these into the controls, which are the ones that basically didn't have anything done, and then all of the rest, which are the treatments that are either mechanical or chemical. So you can see here there's a blue line and an orange line. The blue line is the control with the RB209 recommended rate, and the orange line here is the control with 15%. And you can see basically the reduced nitrogen is senescing earlier, but dies about the same time as the normal crop. So the difference is really only about 2 days for effectively a 15% less nitrogen. You can see the flail here drops immediately. We were left with the previous picture, and it did not regrow. At Spot North and at Spot East, there was no regrowth from any of the flail treatments, and bear that in mind. But all of the other treatments actually weren't significantly different in their rate of decline or the point when they reached complete death. So we're reaching complete death here, typically 7 to 10 days after we've applied RT1s or done our initial flail treatment. This is the Spot North, a little bit more longevity in the canopy, but basically it's dead here, almost dead, 2 weeks, 2.5 weeks after we apply our T1s. And again, the control treatments basically here running the opposite direction, that they're both identical, even though they seem to be reversed in terms of that. They are maintaining themselves, but they still die. So by the time we get to 3 weeks after T1, they're almost dead as well. So it's just the rate and the time at which we get there, but eventually they all do get there at the Spot North and Spot East sites in terms of vine death. So this is typical. Again, I've picked pictures here of Spot East, and you can see there the top left-hand picture. There's a little bit of foliage there, maybe 7-8% after 2 weeks after T1. All of the rest, basically, you've got there desiccated leaves and brittle, dry, white, bleached stems. That's typical of Spot North. Now, Spot West and Spot Scotland. Spot West, again, we had to bring forward nearly 2 weeks to fit with the fact that the crop was beginning to go. It was lodging, but still vigorously green at this stage. So we decided to tackle it so that we've got crops that we actually did have appreciable canopy to kill. So looking at ground covers there, and you can see here we are maintaining the ground cover in the control up at above 60% for a large portion of the point when our chemical treatments and mechanical treatments are having an effect. So they're beginning to decline here, but our controls are staying much higher. So you can see doing something actually within 2 weeks would virtually kill the crop dead, including the flail treatment. Again, there's a separation here, but statistically, there's no real difference. The Soltex treatments tended to be a little bit slower here, but there was a combination of nitrogen rate in terms of an interaction there. If we go to the West, you can see there the control has got appreciable ground cover. 2 weeks, we had 7%. We've probably got the reverse of that, 93% ground cover there in this particular plot. But the rest have got very little leaf material for all of the chemical treatments, but the stems are green and very few bleached and almost no brittle stems at the same stage. So we are taking longer to kill this canopy. If we move to our next slide, you can see now we're moving to a much more vigorous crop. This was the point when we were making a decision in Scotland to spray. And so Scottish Agronomy went out and did the sprays on these two plots at this particular time. So you can see a vigorous green canopy that we've got to target. Tall, not lodged, and in some cases still flowering. So you can see here now the contrast is these two lines at the top are hidden on top of one another. So both the reduced nitrogen and the full nitrogen rate did not senesce over the period from the end of July right through until the beginning of September. So they were maintained. So clearly a crop that was going to be difficult to kill because it was still continuing growing for another 3 weeks. Variable rates in terms of death, the flail treatment here did drop pretty rapidly, but you will see a small blip here where there was some regrowth on the flail. Now, this is the only site common with 2019. Scotland was the only site that we saw regrowth on flail. 2-3% ground cover, but it's still there. It's an obvious thing. It will be slowing skin set, but it will also be a risk for virus and blight management at that stage. Here, you can definitely see a slower rate of kill in the first 2 weeks, but then it does drop rapidly between weeks 2 and 3. And so by the time we've got to 3 weeks, we're actually getting appreciable canopy growth. Notice here the two Soltex treatments actually are significantly slower in actually dying from the application of the chemical. So there we got the treatments, more variable here. Plots are variable. I've tried to give the average picture over the 2 week period. And so you've got the 3 chemical treatments there versus the control. And the flail crop was flailed with virtually no green leaf material left at the time of flailing. So we now look at and say it's a function of skin set. Well, stem desiccation is important because that aids skin set. When we get the brittleness, we've reduced the carbohydrate reserve, reduced the moisture content, and skins will set more quickly. So just a typical example of Spot East here, reflecting Spot North as well, that by the time we've got here 3 weeks and 4 weeks after our T1 application, we've got a lot of brittle stems, 85% plus brittle stems and almost complete brittle stems by the time we've got to 4 weeks later. So we are getting vine death, haulm death, leaf and stem desiccation here. If we go to Scotland, here is 3 and 4 weeks after, we've got no brittle stems at any of the dates that we've looked at, the 3 and 4 week periods, and we've still got 100% stems here with bleaching on all of the chemical treatments. So no brittle, but bleaching. So the stems are clearly not dying at the rate in Scotland as they are at the other 3 sites. So before we go on to what is effectively an immediate pre-harvest treatment around the time we're doing T1 plus 2 or 3 weeks, we were looking to see whether we could repeat some work in 2019 that was conducted in Scotland to see whether we can use a mimic of the cement mixer for skinning. And this is a torque screwdriver with literally a 1 centimeter dowel on the end of it, which is wood. We keep the wood free from soil and we screw it onto the surface of the tuber and measure the torque in terms of Newton meters. So again, as I mentioned about the skin set, when we're looking at skinning in the barrel, you're about to see the cement mixer, I mentioned about 15% surface area. What we're looking here is anything that's above 0.15 Newton meters as a torque should be harvestable without skinning. That's with some crude correlations. That's what we've tend to found from the data from 2020. So what you've got there is, with the exception of the 2 control treatments in the blue and the orange, all of the treatments, by the time we've got 2 weeks later, have just about reached that point of harvesting thing. And that reflects when we measured in the skin set barrel, we've got material here that would harvest. So bear that in mind, a reasonable correlation there between where we've got to with the torque screwdriver and where we'll get to in terms of skin set. However, this is the west site, and you can see there's virtually no change over the period that we measured. And the other thing is the numbers are in the sort of 5 to 6 in terms of scale here, 0.05 to 0.06, so well below that 0.15 minimal threshold for skinning. Here in Scotland, and again, there is a very slow decline, but you will see there the numbers are very well. So we are not getting a good correlation between the screwdriver and the site changes in skinning. In Scotland, it's good because basically we're finding the skin set is very slow and the torque screwdriver is telling us, but there is virtually no change here over time, whereas the next slide you will see we were seeing some change. So screwdriver, we're out on that one in terms of its use and utility for the future. So there's our skinning barrel lined with basically abrasive sandpaper. We skin it for 2 minutes with 4 liters of water, rotate the tubers, and then measure the surface area of skinning. Now, forgive me, because this is a picture of 2019 data where we've got some good skinning on the Royal from the the Elvedon site in 2019. You can see the surface area removed there. We measure that on 50 tubers. Here's a sample I've just laid out for the camera, but you can see skinning occurring there. So I'm going to run through the sort of brackets of skinning east and north versus Scotland and the west. And so we can see here, we're looking for less than 15% surface area. And on T4, which is 3 weeks after our initial T1 application, we've got virtually no skin removal. So these would harvest with quite a lot of abrasion on Mike's sandy soil with virtually no skin set problems. Even the controls reach there very quickly, very low numbers here. And by 4 weeks, we've all got all the same. So effectively, we've got very good skin set here. Now, spot north, you can see here the 2020 data. We're looking for less than 15%. So all of the treatments at 3 weeks after T1 had reached well below the threshold for harvesting. Maris Piper, an indeterminate variety, and we'd still got there. Compare that to 2019, where we had, again, very low values here. We're seeing these 2 sites that were both hit at the point when the canopies were beginning to go down. We got rapid canopy death, and the skin set followed suit. Now, more importantly, this shows a little bit of a confusion here. I'll explain in a moment, but the T4 numbers, which are 3 weeks after the application of initial timings at T1, at the spot west side, show that most of the treatments were getting close to that 15% level. Even the controls were below it at that particular time. But there is one treatment that stands out. We've checked all 4 replicates and the data are real. So we look at that. So we're almost there. The problem was then when the team went back 4 weeks after T1, so another week later, we found a reversal of skin set and nothing was suitable for skinning. Now, basically, we checked the data again here. We checked whether these 2 were reversed. They weren't. And this seems to be an aberration that somehow there, the skins were not setting, the stems were still green, even though the canopy had lost all of its leaves. And this is something that we have seen in the past anecdotally. I'm sure many of you have seen this, that a reversal apparently of skin set. We weren't in a wet period at this time, but the skins certainly were going backwards, and it's reflected in the photographs of the tubers that we've seen. So, Spot Scotland. Well, we made a decision here with basically the team that were operating Scottish Agronomy to say, we are clearly nowhere near skin set at 3 weeks. Can we delay until 5 weeks rather than 4 weeks? And the consequence was that, yes, we did get most of the treatments below that 15% threshold where we did something rather than doing nothing. We actually got there in terms of this. One treatment here, the final SAN, was slower in acting in skin set in this particular trial. But on average, they're almost all there. But it was 5 weeks later. So we've got this parity difference between the Spot East and Spot North sites, which basically died quickly and skin set quickly, and the ones that had difficulty in killing the crop, which was linked to the canopy. So I'm not going to present data on any of the other sites, anything from 2019, just one slide from the seed trial in 2020, which to show this sort of so-called passive bulking. What is the effect of a slow rate of death of the canopy on the yield that can go? Now, if we're growing a crop where there's a fairly flexible size grade and we can afford to move material a little bit higher grade, maybe out of the Baker fraction, and a few smaller tubers come into the bottom level at maybe 45 or 50 millimeters, then effects are really quite small in overall targeted graded yield loss from these treatments. However, in Scotland, you will see the control treatments where we did nothing and they carried growing for another 5 weeks by the time we'd done our last skin set assessment. In the 4 week period from T1 to the point of yield harvest, we actually got material moving out of the seed grade into the oversized seed grade, and we had over 30 tons of oversized material where we did nothing. That's the reason why we do something, and also is the issue about virus and blight coming in and controlling those. But if we look at all of the other treatments, whilst there was some oversize in terms of roughly 12 to 18 tons of oversize, there wasn't any significant difference in the seed yield, but directionally the flail did have numerically the highest number along with the Saltex treatments. But on the average of all of these chemical treatments here with the flail, there was no significant difference in any of the treatments in terms of so-called passive bulking. They all stopped the crop sufficiently quickly to control yield. Now, where they don't, then obviously we may be moving into a territory here. But these data are the only sets of data we've got from 7 trials in 2019 and 4 in 2020 that shows bulking is continuing for significant periods of time in these crops where we're actually not killing them. But the chemical treatments are not materially any different. So why did we get different kill levels? Was it just about crop stage of growth? Scotland obviously was targeted for the end of July, a typical seed desiccation date. Was it about conditions? And so I've summarized the conditions here. And by and large, you can see a lot of the T1 and T2 sprays that were applied, which did most of the effect on canopy defoliation, were applied when temperatures were in the 20s, when we had low cloud cover and relatively average or low humidity. And most of the sprays were done mid-morning. The north was actually done in the afternoon, but they were done later in the day as opposed to 9 o'clock, 8 o'clock in the morning. In Scotland, yes, temperatures were lower, 18, 19 degrees at the 2 timings we had, but that would still be regarded as fairly good in terms of temperature. Light levels were reasonably good. Again, in July, you'd expect it to be high. These treatments here, light levels are good. In some cases, we had 30 degrees. So we are getting good conditions for most of the sites, but Scotland perhaps slightly poorer, but still not the 12 and 10 degrees that we saw in 2019. So in summary, if we look at all of the sites and then just ignore the variation, but look at the mean values over the entire sites that we did in 2020, we're coming up that nitrogen, you'll see in a moment, had no overall effect. By reducing it by 15%, we didn't have any effect on skin set. And we didn't get skin set on some of the sites where we actually didn't do anything. So bear in mind that you can't just do nothing it will take longer to set skins. Whereas the rest of the treatments here, if we look at the difference between the standard and the low rate of nitrogen here and here, there's very little difference. If there is a difference in nitrogen, it's probably, again, 1 or 2 days. The flail versus the spotlight goes eye treatments, the rate of skin set, if you plot it over time, over a 2-week period, and you extend it, then typically the delay on spotlight goes eye treatments compared to the best eye, the flail, is about 1 to 2 days. We're not talking of a week, but we are talking slightly slower, as we observed in 2019. So in summary, there's an overall summary that we did not get any effect of nitrogen. I thought it would be greater than it was. We got some marked effects in ground cover on some sites, but it didn't repeat in terms of skin set. So what have we learned? It's the end of the program from 2 years. Very simply, that it's still Scotland and the west sites that stood out. Now, that could be variety. Royal is a difficult variety to kill. We know that that's difficult, but in the east in 2019, we killed it pretty quickly in terms of skins, set and canopy, albeit the stems were a mechanical problem when we came to harvest, because they did they did desiccate much slower than the skins were setting, or the canopy declined in terms of leaf area. But Scotland did stand out, and clearly conditions play a role there. But the stage of crop growth with no lack of growth, a growing crop, actually did show that those crops were going to be difficult to kill, and reflected that. Now, this has been borne out by several experiments and trials in 2019 and 20. If anything was beginning to tip over and we were losing ground cover, not lodging, but losing ground cover to senescence, a paling of the canopy, then those crops responded very rapidly to desiccation. So how do we get them at that stage to match either our requirement for seed, or for salad, or for wear, burning down at a particular time? That's a target that we really should be aiming for. And nitrogen can control it, but we weren't very successful in bringing it forward much in 2020 by reducing the nitrogen. Overall, the 2019 data showed that Spotlight Gose was only 1 or 2 days slower when used in combination to set skins than the standard treatment Reglone. We lost Reglone in 2020, but the flail and the Soltex treatments didn't show any marked improvement on the Spotlight Gose treatments. Soltex, on average, was as rapid as flail, even at the half rate that we used in 2020 compared to 2019. Now, there were some sites when it was slower in killing leaves, but skin set wasn't materially affected. So again, canopy linking to skin set isn't always the best clue. In fact, it's not a very good clue in many cases. Whilst final SAN, or pelargonic acid, was the slowest to kill leaves, its skin set, which is what we're after, was actually similar to Gose. By the time we got to 3 weeks after T1, it was as dead as anything else. So effectively, the rate was different, but the ultimate point was the same. I mentioned about the nitrogen, that we didn't have the effect we would experience. Maybe 15% wasn't enough for these treatments. There's a lot that could be done in future if we continue this with the application of these PPO desiccants, including Soltex, in terms of the timings, the water rates, spray angles, and so on. And Jim will probably talk about that if you ask him in the following debate. We've had seasons this year where we've had soils, even if they've been irrigated, have been on the moist side rather than the wet side that we experienced in 2019. So therefore, normally we'd expect skins to set rapidly in drier soils than they would do in wetter soils. So that's a target, looking at that, making sure we manage irrigation and stopping, ideally, 7 days before we do our T1 desiccation. The Spot West data, it's an aberrant data set, but it's sort of diluted by the overall effect. Why the skin's apparently unset. This use of a torque screwdriver, I think it's still got mileage, but we're not getting repeatable results from the changes that we see in canopy and the changes we see using the traditional cement mixer method. The passive bulking, I believe, is apparent, but it's relatively minor from the data sets that we've collected across the 11 trials we've done in the last 2 years. And I've not reported any data on internal defects, any pathology of blemishing diseases or rotting diseases, because none of the chemical or mechanical treatments had any effect on any of those variables. And as we know, the regrowth that we've got in flail is important because obviously with virus ingress coming from late season aphid movement, we need to kill that canopy, don't we? So watching out for regrowth on flail is important. So I will leave it there and hand back to Claire, who I'm sure will chair a very good discussion session with the other members of the team.
Thank you very much, Mark. As always, lots and lots to think about. I always really enjoy the desiccation session because it's not just about the product that we use, it's about kind of drilling into more what the market is, and it really shows how it's different across the country, and not just about location, it's about what is it you're growing, what variety. So I'll ask the Spot Farm hosts who are on the sidelines to join us, because they will certainly add colour to this conversation. I know we had a conversation last summer, probably before Jim was desiccating, but I think, Mike, you'd already been quite well through your desiccation programme when we had a conversation last year. I'm just going to ask you guys to kind of, obviously it was quite an exciting debate we had last year, wasn't it? Because you'd all kind of planned your programme and you were taking really different approaches. So can we just recap on what you were planning on doing last year, and then in reality, what did you do last year when it came to desiccation? We'll travel up the country this time. So Mike, can you start, please?
Yeah, sure, Claire. Yeah, I mean, our desiccation strategy has generally been flail based. We've been flail users for a long period of time, in excess of 20 years, and it's quite well suited to our soil types, from predominantly very light sandy loams, and we're operating in a fairly dry part of the world. So our strategy has been based last year around a flail, and then followed generally about 48 hours later by an application of Spotlight. And to be fair, we didn't really deviate too far away from that, Claire. And really what we observed on sort of most of our commercial crops really followed what we saw in the trial that Mark did. And we had pretty comprehensive, pretty good quality skin set in a fairly short period of time. And really backing up what Mark said, I think that was really as a consequence of a lot of our crops were actually starting to senesce. And if they're starting to senesce naturally, that really is a good trigger for most of the desiccation strategies to work quite well. I think the other point that's really striking is the seasonal difference. And obviously we're only year one into the loss of Diquat, and I think it'll be interesting to see how the different seasons throws different challenges going forwards. But really striking differences between the trials 2019 to 2020.
Well, do you want to update us from your country?
Yeah, I mean, basically, traditionally, we're always chemically based, generally using Reglone in the past. Now, in 2019, we hosted a flailing day and flailed 100 acres off. There, I'll be honest, everything flailed off beautifully. We ended up going back sort of 48 hours later with Spotlight, with a litre of Spotlight to the hectare, and it did the job. Quite frankly, I was expecting a very similar approach to 2020. We changed our stance and we bought a flail and went down that route. Now, the one what surprised me, and basically highlighting what Mike said, the difference in a season, I was expecting, we'll go back with a litre of Spotlight and that would pretty much do us. It didn't, basically. And for ourselves, anything that seemed to be already there senescing, it seemed to almost take a slightly longer approach to kill. It almost sort of hung on. And slightly strangely, I know, but we ended up having to go back with another 0.6 Spotlight, another sort of 7 days later, which surprised us really in some respects. That was the sort of only sort of deviation from what we set our stance out from the beginning of the season. So it cost us an extra week from what we were expecting, but that was it.
Mark, I'm going to put you on the spot here a bit. Could you explain why that would be the case? Who got Mark? Would Would that be expected?
Probably. There's a lot of things you could answer in that. So what was your main driver, Will, on that?
Well, basically, still after sort of 7 days after the spotlight application, we still had 15, 20 centimetre short stems, which were still fairly green. We had, don't get me wrong, we had, I'd say, 2/3 of a death across the crop.
Yeah.
But irrespective, it wasn't as though it was an poor application or anything like that. It was completely irregular. Literally one plant side by side. And once we started on that process, I started looking at the crop before we were flailing to see if we can find any correlation.
Yep.
And it's almost as though the one that was sort of, if there was any specific plant which seemed slightly more senesced, as we went around and put some markers on them, they were the ones that seemed to be hanging on a little bit further. And it's almost, I hate to say it, I mean, I'm no pathologist or whatever, but almost as though it wasn't taking in the chemical as fast. I don't know, but that's how it seemed to me.
Yeah, the reason I asked you back another question, it all seems a bit mixed up about what exactly went on. And I'm going to go back to some work. I've been reading a question here about bruising, and we did some work where we flailed crops at the sort of length that we're talking about here, so 15 to 20 centimetres, at the stage that Jim would normally do it. And we removed all of the foliage. So we weren't shredding leaf material. We were cutting it off with a hedge trimmer and then removing it. And those green stems that remained green for 2 weeks. Mm-hmm. In another sequential, effectively harvest, so a week later, 2 weeks later, we did exactly the same thing. The canopy was perhaps not showing the stage that Mike was saying his canopies were out, but it was definitely beginning to yellow. The stems were still as turgid as they were 2 weeks before, and we did exactly the same thing, but the stems died in a week. Yet a week later, the stems from the early defoliation were not there. So we sort of think, well, the rate of stem desiccation, there's something going on in terms of a signal by the plant, but it is very time related. So it might be that you've just got that slight difference of maybe a week in emergence between plants. You would never spot that at the end of the season. That could be the reason why you've got it, but it goes the opposite way to the way you'd expect. That's what I was trying to sit and think about, and that's why I didn't respond to you initially. But it's difficult to explain that. Yeah, because it goes the opposite way to the data that I've seen and what you might expect.
And Jim, do you want to update us from Scotland? Obviously, we're talking about natural senescence. This job's a bit harder for you.
There's certainly no natural senescence up here. We took a 3-spray programme because we're seed producers who don't like to go through with a flail for spreading disease. I have to say it was fairly successful. The big difference in the varieties, Innovator Group 1 variety was easy. It was just as easy to kill it with the PPOs as it was with Regloin. However, the Maureen and the Daisy were definitely a bigger challenge. I was a bit worried about them, but eventually they did go with the 3-spray programme. One thing we did notice in our own trials was that where we flailed green, the 4 lots that were flailed green, all had varying levels of regrowth in them. And we had one lot that did a T1 spotlight followed 7 days later by the flail and a PPO inhibitors after that. No regrowth whatsoever. So there's no question that when the plant's actively growing, if it's flailed, it's definitely getting a message to keep growing. So from a seed point of view at the growth stages, I say growth stage. We don't speak about growth stages in potatoes, but it's just to show the difference that normally Will and Mike will be, and Mark will be around growth stage 90, where we're between 60 and 65 when we're trying to desiccate them.
Yeah.
So it is, and I'm sure that salad potatoes come into that same bracket.
Brilliant. We've got some questions coming in, so we'll try and answer them, but please do keep questions coming across because we'll get through them. So Andrew Wilson is asking about no flail and spotlight, but we have used flail and spotlight, haven't we, Mark? That's just...
In the past, this year, it just happened to be that we can only do so much. It was Go's Eye following the flail application, and then spotlight. So it's sort of a reverse. So I personally don't think there's any difference whether it starts with a G or starts with an S. There's a very similar mode of action for the two chemicals, but I think it's very interesting what Jim says, that, you know, where he spray flailed as opposed to flail spray, then you can reduce, Jim, correct, is this correct? You can reduce the level of regrowth.
There was no regrowth whatsoever in the crop that had the T1 chemical treatment.
And so, I'm a scientist, and you repeatedly get told you get regrowth. Well, yes, but certain combinations lead to no regrowth. But if we flail, as Jim said, a green crop, we nearly always get regrowth in the type of crop that Jim is taking down, either a very early salad crop or a seed crop. Whereas if we do it later in the season when the crop has actively started senescing, you know, there are 5, 6, 7 trials that we've done in the last 2 years that have shown we get no regrowth. So timing has an effect, but if you've got to time it, so you're doing flailing, and irrespective of the disease issues of spreading, you know, bacteria around, but if you are flailing, then using if you like, a T0 application or a T-1 of spray might be well, because what you're doing then is you're conning the plant that it's about to die, and then you may not get the regrowth on stems. I mean, Jim has clearly got evidence from his trials showing it, and we've done similar things of spray, flail, and we've seen no regrowth either. So I think that's one of the things we've been a bit formulaic in what we've done, and that's because we can't have every single treatment that everybody wants. But at the end of the day, we've established some principles. Now is the time to tweak these things, and I see there's stuff coming through about wetters. There's things about this followed by that, and I think we need to go down that route. I've mentioned conditions, but I think spray volumes and either combination sprays could well be done. So that's to open up. Claire.
Well, I know Jim's got a response to this one, so I'll ask you first.
Where to start? The application. We've always used for the T1 application Hypro Gardenier Twins 04s, but we changed to Lechler 04 IDTA at 4 bar. So it's the design of that jet slightly different. It's 60% forward and of the volume forward and 40% of the volume back. And certainly we did have a good coverage. We did a bit with drift retardants that I definitely would say that we saw a difference in the crops where we used a drift retardant and didn't. We also noticed the difference in the partner products, the partner blight products that we used with the different desiccation treatments. So, you know, there's definitely something to look at there. One of the ones that had the worst regrowth, you know, it was a different partner product. So it's something that needs to be looked into, and we need to understand it.
Mike, have you got any, what are you using, and are you looking at kind of water volumes as well, or spray application? Is that something that is in your program, or don't feel under pressure?
Yeah, no, I mean, it's something we look at quite closely. A little bit like Jim, we've used Lechler IDTA nozzles. So on the commercial crop around the trial at Spot East this time, we were, Lechler IDTAs at 200 litres per hectare at 3.5 bar, and that generally, I'm with Jim on that. I think that gives us good coverage, and when we've looked at coverage with water sensitive paper, then that's for that type of application. That's given us good coverage. I think the other point that I'd make is that we've generally found by leaving a period between flail and spray just allows some of that material to desiccate, particularly if the conditions are hot and dry, and that's given us better contact with the stems. Then I think having at least 150 millimeters of stem as a target is important. I think just physically to get the amount of chemical deposition that you require to get the effect, but also from a harvesting point of view is given something for the horn rollers to work on when you're lifting that crop. But yeah, I think historically most of our applications have been flail and then a spray, say 48 hours later. Some of the seed crops that we're growing, some of the varieties there, then we have gone in with a PPO in advance, like Jim. I would agree with him. I think we've seen far fewer issues with regrowth where we've done that before flail, and that's certainly when we had Diquat. That was a strategy we used to use with Diquat, but we're starting to try and learn a little bit with doing that same strategy but using PPO inhibitors. What else was I going to say? I was going to say something else. Sorry, it's gone blank. I'll hand back to you, Claire. It'll come back to me.
That's okay. We'll pop over to Will just to see what you're doing. Are you?
Yeah, I'll be honest. We haven't actually tried the molecular nozzles at all. It's actually something I think we should be doing to have a little play with. We are generally using the 04 Guardian Twins forward and reverse facing nozzles. One thing we have played around with a lot is water volume, and generally we're finding a better hill with slightly higher volumes. So 300. Well, we certainly went to 300. We ended up to, I think on one part we actually tried 500. Admittingly, it just gave that difficult trying to put that amount on at times. Logistically, it was a bit of a nightmare. But certainly, we've generally been basing ourselves sort of like the 250 to 350 in litres to the hectare. Generally, again, as Mike's been saying, a horn long enough so the horn rollers can get hold of it, whilst also a good target for that actual chemical to hit. One thought I have had for the future is whether we can almost ban spray to a certain degree, but that's probably another jump further on. But it's something I haven't ruled out ourselves anyway.
And I'm going to move on to another question here, which I think follows on, because is there any negative effects to flailing? And it's been asked directly to Mark, but with question kind of underlining blackleg and blight, and I think I'll throw that question out to everybody, because we're talking about the burn down, but what are the side effects, and do you see that in the field? So obviously water volume is that's a big question when we're thinking about blackleg, isn't it? Well, is it? But I'll let Mark answer it first, but I'll kind of ask what the kind of practical implications of that when we're thinking about blight and blackleg as we go through desiccation programs.
Okay, well, I'll throw a bit of a curveball where I'll let Jim and Mike, because they're practitioners, and Will on flailing. But we were involved in the work with Syngenta on re-establishing recommended rates for Reglone back in 99, 2000, 2001. And I just want to say that, this spray flail type approach, David Furman, who was in charge of the work at Cambridge at the time, basically was using as lower rate as 0.5 litre of Reglone. And there were crops down in Wiltshire that looked similar to Jim's that were 90% of the leaves were removed within 3 days of actually applying that 0.5 litre. So I think there's a question here. I'm trying to answer as many questions as possible in one go here. But, reduced rates, I think if you hit it with a reduced rate, say 0.5 litre of Spotlight or reduced rate Gozai, you see the consequences. You've still got armory to go back in again. So that's it. And I think pre-flail spraying, I think 2 practitioners here have said, we see less regrowth. I think that's a real, takeaway point. We haven't followed it in our program, but, you've got evidence there. Maybe there's some more investigation. But then I will go back and say some of the work that we were doing was to try and prevent internal vascular defects and stem end necrosis as a consequence of applying high rates of Reglone, 3 and 4 litres per hectare. And the split dose reduced the risk of that, didn't eliminate it completely. But one of the things we were comparing was mechanical flail treatments versus chemical. And the mechanical were equally as bad if timed at the wrong time in terms of vascular defects. So if we saw vascular defects, they were across all treatments, and it wasn't associated with Reglone. So I think one of the things you've got there is if you're trying to kill a crop rapidly, and the crop, and I think this is Shale's point, if a crop is being dried out to try and get the soil to aid in the skin set, but you leave it too long and the crop becomes desiccated internally, so it's dehydrated, and then you flail or you kill it quickly with a chemical, you can develop internal defects. And so that is a warning for people in terms of, if we're trying to get it, do not have crop stress associated with the time of burn down time. Now, if you're in an unirrigated scenario, there's not a lot you can do, but just be warned about that. So that's a flail and damage issue. So Mike and Jim and Will can sort of take over from their points.
Just for the audience benefit, because I don't think they see the questions, Daryl's asked about the potential effects of bruising and having dry soils at the start of desiccation, which Mark answered.
I answered, so it's a week, it's not 3 weeks, is the answer.
Yeah. So, Will, do you want to kind of, in practice, what does that mean for you?
I'll be honest, practice-wise, for flailing, we've only really sort of come onto the scene this last, the 2020 season with our own flail. It is a big concern to me and to the business of blackleg, effectively those spores and all those open stems. We're still to see major issues, but they are relevant there, and a big concern to us. Practically, as I probably said before, I've got no issues with our wold land as far as being able to flail. It's more of our silts, certainly in slightly wetter times. You get that compaction, you get slight nipping on the edge of the rows. And I would say this time we have seen that and potentially had a slightly increased of greening because of that, just whether, even with the best tractor in the world and the best operator, satellite, and or machine satellited up, you still can get that slight nipping on the edge of the rows, and you still get that compaction just pushing just ever so slightly into the rows, which then can create harvest problems. On this silt land, but on the wolds, I'm not unduly worried at all, practically for that. Yeah.
Mike, do you see kind of different approaches on land you have as well? Or is that something that you're taking into consideration in the programme?
Yeah, I mean, I agree with Will's comments about soil compaction, and the majority of our soil types are quite forgiving from that point of view. They're very light sand-based soils. The downsides of flailing really are, in my opinion, we plant headlands, so the flail tractor is having to run over 2 beds on the headland even after he's crossed the internal. So that can cause issues with harvesting when you're harvesting those headland beds. Will's right. I think particularly if it's very wet when you flail, sometimes you can get soil that smears up, pushed up the side of the ridge, and then if that then subsequently dries out, it becomes quite hard. You can get a lot of clod potentially up the harvester. So even on our lighter soils, we have to be mindful of conditions we're flailing in. They are more forgiving, I think, than a lot of other parts of the world. I think, from an idealist, from a crop, what's right for the crop, I wouldn't flail crops and spread bacteria around. I think as a starting point, that's something you try to avoid. I think we get away with it in our climate, to be honest, to a larger extent than other parts of the country, because we are predominantly seeing high temperatures and dry conditions. But I accept as a grower that's not an ideal standpoint, is from a flail to be actually spreading those bacteria around the crop as you're then defoliating and giving entry points for that bacteria into the plant. Just a comment on Daryl's question. We work quite hard to avoid flailing crops that are dehydrated, and so we probably on our soils we'd probably be less than a week in terms of the cessation of irrigation and flailing, particularly where a crop is starting to nest and mature naturally anyway. We would find probably we'd have issues with bruising with harvesting some of those crops. So we're trying to make sure that we've got good plant turgor, or as much plant turgor as possible, and we'll often flail early in the morning and stop. We won't flail in the afternoon when crops are likely to be more dehydrated as well, in an effort to try and mitigate crop bruising. Thanks, Claire.
So I'm going to go back to you. Oh, sorry, Mark, I'll let you jump in first.
Yeah, just before Jim goes on, that's very much emphasising the work we did back in 2004, 2007, is the rate of change in between 8 o'clock and 12 o'clock can mean that you can actually harvest a crop bruise-free at 8 to 10, and by the time you get to 12, but it is dependent on conditions. So the hotter it is, the drier the soil, the greater the effect. And if it's cool and dull, you could harvest the whole day and still not bruise. So it's that dehydration. You can certainly get enough in a day to cause bruising, but it's diluted if it's dull, effectively. So, yeah, sorry. Yeah.
That's awesome. So, Jim, I know that the challenges are slightly different. I just wondered if you wanted to talk through kind of what, well, you've taught me over the last kind of 18 months in terms of, we thought it was blackleg that we were looking at, and then it with all these issues, it actually turns out it's other things that we need to consider as we go through. So I don't know if you want to kind of talk through what you were trying to achieve or solve and what we're
when we started doing these desiccation trials, it was based on blackleg levels with different treatments. It started quite by accident. I'll not bore you with the details, but we saw in certain susceptible varieties like Premier or Maureen, Amora, there was big differences in the blackleg levels with the different desiccation approaches. One point I think I'd like to make with a T1 chemical application is that 100% of your applications landing on the crop, and it's well said that looking at band spraying behind a flail so that the chemicals concentrated on top of the rows is definitely something that should be looked into, but should we be trying to shut it down twice while the crop's growing before we go in with the flail, just to make sure that PPO inhibitor's in the plant? Certainly something that we'll be trying this year, different levels. I'm not sure, we actually mixed two, just like the replicated trials where we mixed Gozai and Spotlight together. But if we split them up, we could actually load the crop with a full rate of PPO inhibitors within 14 days without going against label recommendations. So that's something that we'll definitely be trying for this coming season. There's a question there about passive bulking. From the best and the worst treatments that we did this year, there was 3.5 tons per hectare of a difference of saleable seed. That's on a 35, 55 riddles. So it was a fair bit, and the worst ones were the flailed ones because there was more oversize.
Mark, I wonder if you can kind of help answer that question about there's a question coming from Rob Scott about the data showed little difference in passive bulking, and what would the typical passive bulking be from T1 to final? And obviously, Jim, you were seeing that there was passive bulking in other trials that you were looking at, didn't you?
Yeah, so Jim is almost totally right. I would say 3 tons per hectare. And, often at that stage, it can be marketable because material moves out of the upper grade, but also material moves into the lower grade if you're lucky. And hopefully it balances. But there's certainly over that canopy death phase, it's typically about 3 tons per hectare. We've not found any chemical differences between chemicals, but you would expect that if you kill the crop dead. Now, the treatment that we did in 2019, where we basically home pulled, we pulled the home out of the ground and removed the connections to the roots because the roots were broken off. We removed the stems and the leaves so there's no photosynthesis possible into tubers. And the other one was we actually removed the stolon connection so the tubers can't rehydrate or dehydrate. And that was the only one that stayed still. So as Jim said, the flail did actually increase in yield, but it didn't increase in dry matter yield. It just increased in water content and diluted the dry matter. We've done a lot of work on this in the Bruise program that I was talking about answering Daryl's question. And so it's dilution that we're getting where the material is basically killed quickly. If the soil is wet and you've killed an actively growing canopy, then the roots will take the water up. And so you can't stop that unless the soil is dry. And we know, we just talked about, the disadvantage of doing that. But where it's a general slow death, we're saying about 3 tons per hectare. So that sort of answers, Jim and I have answered Rob's question there, really. It's measurable, but you need to take a lot of samples to detect differences of 3 tons, but that's what I would expect, and Jim's backed it up.
Okay, and so there was a comment, I think, Will, you said about not using any chemistry to burn down, but I know, Mike, you use a green burner. Is there anything that you kind of learn from that approach in terms of the more organic system? Is there anything that we should be seeing from that? And I suppose then, naughtily, I've kept the question about costs alongside that same question. Someone else has asked about the cost of these different approaches, so maybe we can add the green burner into that question too.
Okay. Yeah. So we grow organic potatoes here in the business, and in terms of achieving skin set, then that's really been driven by the use of the flail and the green burner. We're growing salad varieties basically. So we're trying to, and obviously, manage nutrition. And often nutrition can be more limited in those crops anyway, but generally we're flailing and then green burning. Typically, I would say we have to green burn twice to control the regrowth, but also the other issues that we can have as well is that we can actually have weed growth post green burning as well that can obviously then cause us harvest issues. So obviously there's no herbicide applications, and in long term organic land, then potentially there's a bigger weed bank there as well. So generally we've achieved relatively, I'd say, equivalent speed of skin set through 2 green burnings. It's not cheap, but I would say generally we've been achieving skin set in about 4 weeks. We're pretty keen to get stuff out of the ground. Obviously, we've got a higher black scurf risk for those crops. So as soon as they are skin set, then we're pretty eager to get them out of the ground. In terms of cost, then, a single pass of green burning is costing somewhere in the region of circa £100 per hectare when we take into the average forward speeds and current gas prices. That's off the top of my head, Clay, put me on the spot a little bit, but last time I looked at it, it was somewhere around about that sort of level. I suppose a PPO, a litre of Spotlight is going to be circa, I guess, sort of £27 per hectare.
Yeah. I don't know, Will, do you have a kind of comparison of costs when looking at it? Is it something to consider?
We've certainly seen a dramatic increase of costs compared to our normal flailing in 2018 and 19. Not just obviously the difference in labour, but obviously we've had to depreciate machines, diesel, all that factored in. It's actually been an increase, let alone this compaction which I've talked about, and the actual slower in harvest. That hasn't even been recorded. I'd say as a percentage, they've gone up about 20%. As far as so quite considerably. Our costs as far as desiccation is concerned, compared to our normal traditional method prior to losing Diquat. So so it's been quite considerable, really.
Jim, do you have any cost comparisons when I know we're starting to look at that, but I wonder if you have any.
With our 3 spray approach this year, we'll just be like, well, we'll be about 20% more. But if the flails in that equation, it would be more. Right in this area, flailing's about £70 a hectare. And what Will's saying about slowing the harvester down, we've noticed that over a number of years that it spoils the sample of potatoes that are going into the trailer, as well as slowing the harvester down by as much as 2 kilometres an hour, just because of the clods that are created with the flail tractor. Nutrition-wise, we actually use a sulphate of potash. We use a compound fertilizers, and everything goes on with the planter. And the trials that we did comparing muriate of potash and sulphate of potash this year, there's no question that where we've used the SOP, that we've got a much more upright stand of crop, and the growth habit of it, I would say, lends itself to good application of the desiccants, where the MOP, although it didn't go over as much this year because it was a dry year, normally where MOP's been used, the crop can completely lodge, so then it's not as good a target to spray as an upright crop.
So I've kind of deliberately kept the nutrition bit to kind of our last kind of 15 minutes, because I think ultimately what we've talked about is all going to come, for our planning for now, is all about that nutrition at this end, to see where we're ending up for desiccation and what job we're trying to do. So James Lee's put in a very pertinent question about the RB209 N rates look to be considerably lower than many growers like to use commercially. If the starting N rates were to have been 30 kilograms per hectare higher, do you still think reducing N rates wouldn't have had an effect on skin set? So I really this is kind of what I want us to get into and finish on is how do you set up the field and set up a planting to make the job easier at the other end for desiccation, and obviously that then comes into skin set and so much more. So Mark, kind of tee you up for this one, and I know I think we can go around this a bit more and really get into why that matters.
Yeah, I mean, it is an easy question to answer, but it's also a very difficult one, as we've sort of alluded to throughout this talk, is the seasonal variation, the site variation, and so on, that predicting accurately a level of nitrogen that is going to be optimum for that crop in that year is a numbers game of working to the best average. And so Jamie is quite right that we looked at every site, given the details that people like Jim and Will and Mike fed me in terms of previous cropping. We know their location, we know they're irrigated or unirrigated, we know their winter rainfall. We didn't have any nitrogen availability data in the soil, but we made the standard RB209 recommendations on that. And even if you look at the highest rates of nitrogen, which would probably be at Mike's, that if you're looking at maybe 180 kilos, then you're only knocking off, 15% of that is 27 kilos. That's not very much as an increment, and it's certainly probably about the error margin that we'd have in RB209. So Mark Allison, who's one of my former colleagues at NIAB, we sort of worked this through and said, well, that's an average value. Is it towards the bottom end? Maybe for some of the crops. So maybe Mike's crops might have been near 190. And talking to Mike, he probably was nearer that. And he certainly top dressed the surrounding crop by another. Mike, could you help me out? The commercial crop round our trial, you did top it up with extra nitrogen, didn't you? So
I did, yeah. Yeah, no, that's okay. No, the commercial crop had 240 kilograms of nitrogen in total.
Yeah, so we're looking at another 2 increments beyond that, and the crop only lived another 10 days. So therefore, I feel that the data that we've got do show that on an average wear crop of 180 kilos, which is pretty close to what is applied on average to main crops, then 30 kilos less isn't having much of an effect. James's question asks it the other way around. Maybe we're a bit low and many growers would apply more. And Mark Allison's work with the AHDB Grower Collaboration Programme and the Spot Farm work that Claire has been organising or has organised with Spot Scotland has showed that slightly less than that, 28 kilos, is associated with a yield increase of pretty close to 4 tonnes per hectare. So I think where Jamie is probably at the level where we could reduce for optimising yield. But if you go the wrong way, i.e. more nitrogen, you'd actually be delaying the crop in terms of skin set. We didn't test it, it was put forward. Shouldn't we just increase nitrogen to test the theory that what most growers do is wrong? I'm very loath to go back that way. I think we should be trying smaller amounts of nitrogen. We had no detrimental effect on yield, and we only changed the rate of skin set by perhaps 1 day, even less than that, by reducing by that amount. The key target would be people like Jim, whereby clearly the 80 kilos there, we need a lot less than that to grow the crop to get it to die at the point when we can also get it to be turning over, the point when our chemical control is going to hit it. So I think that's the key, where your crops do senesce, then we've got a better window of manipulating nitrogen within a small window. But whereas it's the crops that we had very big difficulties killing, that probably we could be looking at 40 kilos, 50 kilos less as a trial. We never tried that. So that's,
this is like from the stuff that's coming through, this is such a pertinent question, isn't it? We've got questions about is there still true SOP, not just MOP, bubble through sulfuric acid, to make chemical produced SOP? So I don't know if someone can break that down, but also we've got farmers, Andrew Wilson again saying about encouraging results from polysulfate, which is the nearest they can get. So it feels like this is something that people are really kind of playing with and trying to get that right approach for their crops on farm. So I don't know, Mark, if you want to respond to that, but it would be interesting to see how are you managing to, can you take that risk of how resilient does that crop need to be to get to the end, but also realistically the thought of not having enough kind of energy in the crop to get to the end is also I'd say a scary decision to make, isn't it, when you're actually talking about trying to grow a crop of potatoes. So I don't know if we can, Mark, if you've got a response about the products to use, or do we want to go straight into what are we actually seeing on farm?
I'd rather. I'm sitting on the fence. I normally don't do this with the product. There's opinions and whatever, but no. But what I would say this year is one of the things that is more universal is that the very high light levels that we had when crops were establishing, end of May, early June for many of you, light levels were high. Basically, what you get there is shorter canopies. There's less internode extension. So even with the same leaf area index, layers of leaves, the canopy's just squatter. So therefore, the issues then it's probably more favouring leaf and less stem. So therefore, you've got less stem to kill, and there's a lower risk of it lodging. Now, then Jim added the bit about the type of potassium fertiliser he was using. It might be additive. I'm going to stay out of that one. But clearly, you can't do much about light levels. But this year, it's like the perfect storm. We again got very good conditions for killing crops. And when this program was started, it was the difficult to kill indeterminate varieties, particularly seed crops. And we've identified that the seed crops are the difficult ones to kill in Scotland. And so the focus there is Will's had some problems. Mike, I think, has probably worked around it a bit better, but Jim is clearly the one that has got the big target issue, and nutritional management there might be the real key. So,
Jim, do you have a kind of response? How do you walk that tightrope? How do you do it?
Again, it was just it was just because we used 2 different types of fertilizer in the same field probably 6 or 7 years ago that we noticed that difference where the MOP completely lodged, and it was even more even with the Reglan, it wasn't such a good target. So we've stuck with this. It's not a cheap option. but we've definitely had better results. We have better tuber numbers, which is obviously more important for us than the total yield.
And Mike, do you find that, like, do you have to, obviously it's not such a big issue, but do you have to make that decision at planning stages to kind of decide, I'd rather take the pain at the end, or can you manipulate it now to make sure that you kind of reduce those risks as you go through?
I suppose my approach to it is, and I'd probably start off by caveating it by saying it's probably one of the things that we do most poorly, and it's one of the biggest challenges in terms of ground potatoes, I think, nutrition. Lots and lots of seasonal variations, but I must admit, desiccation is one factor in the nutrient planning for my crops. So first and foremost, I'm planning to grow a crop of potatoes, to grow a good crop of potatoes and hopefully make a margin and profit. So that's where we start off from. And then we look at our historical performances, our knowledge, the varieties we're growing, what we're trying to achieve in terms of tuber numbers, in terms of tuber size distribution. We take into account what is in the soil, which generally in our case is pretty much zero. It's certainly in terms of nitrogen, and then we base a plan from there. What we probably not great at, we have done a bit of it in the past, is trying to audit how successful we are in terms of putting nitrate into the crop by taking PTO samples throughout the season and trying to monitor it a little bit there to audit our success, if you like. The other thing I'm always quite mindful of is that, I'm aware that potatoes require a lot of their nitrogen fertilization early in their development, which in our soil types can give us issues in terms of nitrate leaching if we're not careful. If we have big rainfall events, or as we are irrigating a lot of irrigation, and potentially we can lose nitrate out of the soils, which is something we're working hard not to do, but we have to be mindful of that. So certainly, desiccation comes into the factors that we're considering, but first and foremost, it's quite a complex decision-making process, and we're trying to grow the yield in the first place and making decisions based on that. But yeah, it's certainly seed crop wise, a different scenario where we're physically trying to stop a crop growing that's really only halfway through its growth cycle. Then we were much reduced levels of nitrogen in those crops.
Will, do you have anything kind of to add on what your approach you're taking?
Yeah, well, I'll be honest, very, very similar to Mike in the form of, we're trying to make a crop, create a margin. In some respects, slightly differently, that we've generally got some very good soils where we're not just sort of starting from zero, as we've found in the past trials, which Mark has carried out on here. One thing this process also has highlighted to us is that, in actual fact, we have reduced nitrogen dramatically, not just for desiccation purposes in the past, which up until we're flailing, was a big factor. Certainly for some certain varieties, we were basically struggling to kill. So, and in some respects, we have cut back 50 to 60 even kilos of nitrogen to the hectare, depending on varieties, across the board, which obviously helped the bottom line, to be honest. And it's also, I would say, increased yield and helped with desiccation. So we've been there over the past, I'd say, 4 years, and dramatically, cut back each season. It's always that the nervous factor, I would say, of actually how far do you go. And Mark was initially saying, you're 40 kilos too high, we were. I mean, basically cut back 15 kilos this year, 15 another, and another 10. So those factors certainly have helped us as a business, quite dramatically, to be honest. Again, we are putting, we've sort of concentrated a little bit more as far as actual placement fertilizer and also the correct fertilizer for the correct field. Altering potentially the type of fertilizer for that type of field. So there's not been any one specific fertilizer we are saying, right, we are using across the board. And it even alters from whether it be a silt. We could put 3 different types of fertilizer on. Not on the same field, but on a field by field basis. And again, on the wolds, we could alter that 4 times over. And basically utilising the correct fertiliser for that correct field and using each individual one for its correct benefits. In the end of the day, for us, yield is king. And when I say yield, it's not just that tons per hectare; it's that pack out yield. Actual saleable commodity. So yes, that's basically what we're aiming ourselves at. And then, rightly, wrongly, now desiccation's taking, I'd say, not the back seat by any means, but maybe being number 2 to yield. Certainly while we're under a flail regime, I'd say we'll still carry on down that route. So yes, that's basically where we are at the moment. Anyway.
Mark, did you want to come in? There was something you wanted to add.
Well, I'm conscious we're running out of our scheduled time slot. We've used almost the entire period. But just to back up Will, it's an advert for you, really, Claire, that the work in Scotland was about nitrogen as well. And my advice was to reduce the level of nitrogen down to the sort of area of 179 down to 147. So Will's talked about 40 kilos. And in that particular case, we were about 30 kilos, and I was comfortable with that. And then next thing I know, you're doing 90 as a trial, and I would not feel comfortable with that. And actually, it still yielded in the same way as a pack out through the pack house. So I would not. That's when I get nervous. And Jamie's comment was, I feel comfortable with the slightly reduced rate because it directionally puts it forward to helping skin set. But I wouldn't reduce it by 30 kilos as a way of trying to stop a crop completely. I mean, it's just an additive effect, and a small amount less will be helping in the right direction. It isn't a big cut, but Will's been there, done it, and we'll support him with data on what he did. He did a lot of work, and we took trial data on it. So
yeah, so as Mark says, we've only got a couple of minutes left, and I will probably draw the session to a close. I always really enjoy this because it's like we started out talking about desiccation and we get into nitrogen and everything else, and planting, what machines are you going to be using? And I think that's the delight of being part of a network of the strategic farms, because actually you get into what is the reality of what the job is we're trying to do. I don't know if we got some take homes from everyone. I'll kind of ask everyone just for kind of plans for 2021 when it comes to desiccation. What's your take home or your challenge for this year to try and achieve? I'll start with Mark, and then I'll go around and just kind of a brief take home from this session and where we've moved in the last 12 months.
Right, it's trialing. I think Jim's mentioned it. Trialing things that we've heard in this talk and saying reduce rates ahead of flail. Reduce rates, observe, see what it is, and you can always go back in with the other half of the chemical 4 days later. Yes, there'll be more passes through the field, but you might be surprised at how quickly the crop dies. So there's a lot coming out of here. Nozzles and spray volumes are there to be investigated.
I'll travel top to bottom this time, top of the country. Jim, what's your take home?
Well, just exactly what Mark said. We will be looking at different rates, and I think we're trying to get the full load of PPO inhibitor on in a shorter period of time within the rules for the seed crops will be important. There's one question that nobody answered, was about air assist sprayers. We didn't compare air assist sprayer, but one thing that we did notice last year in the pelargonic acid, where the sprayer had travelled and turned the leaves on their back, the pelargonic acid worked really well. So this year we actually mechanically tilted the 3 rows inward desiccation trials, and it was chalk and cheese the difference putting that chemical on the underside of the leaf. We've got the pelargonic acid actually stood out as being one of the best ones, where it was last year where it hadn't been tilted over, it was the worst. So we still have a lot to learn.
Sorry, I'm getting lost in my geography here.
Yeah, I'll be honest, I'd back all that up. And yeah, we're going to be still carrying out an awful lot of trial work for ourselves. And I would stress every farm is very different. We're certainly going to be looking at different parts and different nozzles. Still play around with our water volumes, I would say. We're still going to be having a look at. Using just different amounts of chemical at different times. So we're certainly still going to be having to play around with that. We've certainly, obviously it's a very, very relevant subject. No one seems to have the silver bullet. We've lost that now, and we've got to work without it. So each farm's got to find its own way to a certain degree, and hopefully use us guys as being able to use us as examples and see what's what and our own experiences. And that's really what today's about, right?
Yeah, absolutely. Thank you. Mike, have you got anything to kind of what's 2021 going to bring for desiccation?
Yeah, I think for us, like Jim, I'm quite interested in looking at PPO applications and loading up certainly price floating on our seed crops. I think we can improve our seed crop health by doing a better job of desiccation of those. We'll continue to look at different water volumes and different application techniques. And the other thing that I'm quite keen to do is just making sure that we're just monitoring the effects of application conditions. And I think sunlight, making sure that we are really having a good record of application conditions and see if there's any correlation between the speed of skin set and desiccation quality as a result of application conditions. So I personally think that can make quite a difference, to be honest. So those are the three things we'll be focusing on for the coming season.
Brilliant. So the spot programme is in safe hands, as we've still got plenty to look at, and hopefully we'll get to see some of it out in the field this year. First, I'd like to thank the audience for fantastic questions and keeping our heads scratching of what we're to do next. And then secondly, to the panel, it's always wonderful to kind of get everybody together and actually, give Mark some difficult questions of why things are happening, but also just kind of share those experiences across the country. And as we say, there's not a one-size-fits-all approach to desiccation, and it spreads out to lots of different issues in the potato field that we're all being challenged with. The Spot Farm Results Week, this is what it's all about, getting together and actually thrashing out these results and thinking, what does this mean for individual businesses? Please do keep track of what's going on. I know Mike, Jim and Mark are all going to be in sessions later this week. This afternoon at 12 o'clock, we've got a PCN session looking at trap cropping. And then this afternoon, there's a weed control session. You will get your basis points for joining us. And please do just keep in touch. And thank you very much for joining us and keeping the Spot programme alive. So thank you.